Oh, okay. The recording has started.
Did you not mean to do that?
Well, I'm a minute or two early, but not a problem. No, I didn't mean to do that, but
It's okay. Sometimes it's a button that people push. I'll pause it.
I've been doing. There we go. And I have been doing some research recently on the whole question of scholarly searching using artificial intelligence, how well it works and how well it doesn't yet work. So it's a topic that I thought was worth having a conversation about. Hopefully everybody can hear me. If anybody wants to give me a thumbs up, that would be useful to know that people are hearing me. Good. Now I just have to get the screen advance to work, which it's not doing at the moment. There we go. Okay, and I have turned on the recording, and we'll remember our sponsor, and we'll get started. So as I say, I wanted to talk about the problem really of concept identification using keywords for scholarly searching and how that does and doesn't work with artificial intelligence. I think as anybody who's done a lot of library searching, helping people find their research knows what online searchers really want is for an online search tool to find the concepts that they are seeking based on a few simple keywords. We come to sometimes jump to the conclusion that the computer, well, frankly, for many people who haven't used it a lot, can read our minds. Now, there are lots of artificial intelligence tools out there that say that they can do this. I've got a couple of quotes there, one from a piece of software called Splore Human Centric. And Splore says that their search engine can understand your intent and the meaning behind your search, not just the specific words that you enter. Scholarly science is a little more measured in their statement, saying that their system extracts meaning and identifies connections. But again, this is really basic stuff for people who work in libraries, that anytime we're searching keywords in Google, in a database, what have you, particularly if we're searching for a complicated topic, what we're trying to do is to put some keywords in that sum up some concepts and then find the articles that present each of the concepts that we're looking for. As I say, this is really basic stuff. Hopefully all of you will have seen Boolean Circles fairly recently. As an example, I took a look at an evidence-based research paper about how to get workers to use respirators and other respiratory protective equipment. And this is an evidence-based study. And of course, as I say, what those researchers were attempting to do was to find all of the literature to sum up the concepts of behavioral incentives, ways of getting workers to do something, the concept of workers, and the concept of respiratory protection. Pretty straightforward stuff for people who do a lot of searching. This is the keyword search that they used for their evidence-based study. And again, these are really common, and this is just a good example. That's a wall of keywords. It's a very slow back and forth process to come up with all the keywords that could possibly be used to describe each one of your concepts. It's not a simple task. And it's the reason why we are all hoping that AI will do all of this for us or do some portion of this. And there's no question that artificial intelligence methods, not so much large language model that ChatGPT is using, but natural language processing, semantic machine learning, those methods absolutely can look at a large body of information about scholarly articles and can derive concepts from search from keywords and can make connections between words that are used in one situation and other words that may have been used to describe the same concept. So they can do that. And we really have every reason to expect that these AI methods will really change the game for how online searching and scholarly online searching gets done. But I don't think we're there yet. So for right now, the success of AI methods is absolutely dependent on how good the metadata is. The more detailed the descriptive metadata, the descriptions of articles that an AI tool has to look at and compare, the better the search results are going to be. The better it's going to be able to pull concepts together from the words that someone types into a search box. Subject headings or journal classifications, and there's this whole class, all the different ways in which things can get classified. Doesn't necessarily have to be headings for individual articles. It can be classifications applied to the journal that an article appears in. This is one of the things that AI can do if it has the metadata, is to look at all of the context in which a particular article appears, including going on and searching what are the subjects of the other articles that a particular scholarly piece of material might have been cited by. So it's, there's some really powerful possibilities here. And of course, when we talk about AI searching, with something like Elicit, something like, the Semantic Scholar, these tools are using hybrid searching. In fact, they are using keyword, all of the traditional techniques that are used by Google or any other search engine, in addition to hopefully augmenting those with artificial intelligence. But as I said already, detailed abstracts, the more information AI has to work with, the more subject descriptive the titles are, the better AI is going to be able to do concept determination. Subject metadata in particular is a critical way of improving AI's ability to determine from the words you use what concepts you're really trying to search for. So if you get metadata coming from an indexing source that has actually taken the gone through the resources to attach subject headings to each article, all of a sudden subject headings take on new new value. The AI can then determine things like, if you have a subject heading for vapor hazard or dust abatement, an AI can make the determination that those articles are about or concern the concept of respiratory protection and should be included in that concept. In the same way, as I say, sometimes all you've got to work with is journal classification, but an AI can determine that an article that talks about air quality, perhaps if that article appeared in an environmental studies a journal that has been assigned the classification of environmental studies, maybe it would be less interested, but more interested if the article was assigned the classification of being an industrial safety journal. So as I say, subject information is critically important to getting good results from AI. That having been said, as again, limited or inconsistent metadata that comes from different sources and doesn't necessarily use the same headings, all of those things will affect artificial intelligence search success. And right now, most of the sources that we have that are doing artificial intelligence searching lack really complete and really good quality metadata, or at least their metadata is very inconsistent. Semantic Scholar is one of the most popular sources for artificial intelligence enabled searching. It's a wonderful resource, something like 200 million articles coming from 60 different sources, both open access and private. But it relies pretty heavily on open access sources. It gets subject headings where it can, but it gets them from different sources. They're not particularly consistent. And I've done, some limited amount of research on it, doing test searches. And my finding is that 25% to 40%, depending on the search, The metadata that's available for in Semantic Scholar is not even not even abstracts, no title information or no subject information, basically just author and title, table of contents information. And it's going to be difficult to do the maximum amount with artificial intelligence with that small amount of data. Well-known sources of metadata, if you want to see them that way, like Web of Science or Scopus, proprietary, for paid services. All of them are working on rolling out artificial intelligence enhancements to their searches. I think both of them have beta tests going on now. These are resources that we rely on. We rely on their curation. They're dividing articles, journals up by classification, and of course, showing us the journals that get the most citation attention. But they rely on metadata that's coming from many different sources. So it's inconsistent. They don't assign their own subject headings. They rely on author keywords. They have journal classification, but they don't have article level subject headings. So again, what can be achieved with artificial intelligence is somewhat limited by the limitations of the metadata. And for us working with people as searchers, it's important for us to understand what the limitations are at this point. Now, this is just a couple of examples from the respiratory protection search of entries from Semantic Scholar. As I say, the Semantic Scholar is, one of the largest bodies of metadata that anybody's put together. It is the one that's being used by Elicit. I think Research Rabbit relies on it. A number of other resources actually use this, that large collection of scholarly material put together by the Allen Foundation. But as I say, a high percentage, depending on the subject you're searching, quite a high percentage of the material that they're looking at, they're relying on the title of the article, perhaps a journal classification. But that's the extent of the amount of information. They don't even have an abstract for an AI to look at and try and figure out what are the concepts that are being discussed by this paper. So clearly, changes to the scholarly content landscape, to the whole environment, are going to be needed before AI really comes into its own, really does what it could potentially do. And it's a wonderful opportunity for us to get discussing larger questions about the scholarly information landscape, the whole question of the divide between open access materials, freely available metadata, and things like Crossref or OpenAlex, as opposed to proprietary metadata in the paid paid subscription databases. Right now, when you do a search with a mixed bag of open and proprietary metadata available, a mixed bag of quality of metadata, obviously the sources with the best metadata, the ones with consistent subject headings that can be looked at, there's a certain bias in the results toward those. So clearly, if you search Semantic Scholar for a medical related topic, you're going to get better results than if you search Semantic Scholar for an entirely social science based topic, simply because the metadata is better. And that's a problem, but it's something that one needs to be aware of when working with people using this tool for searching. Of course, for-profit publishers restrict access to their metadata. They may release portions of their metadata to open access sources, but metadata is a valuable commercial commodity. Their subject headings are one of the selling features for their databases. their incentive to make that information freely available, or to make it cross-searchable or concordant with other people's subject headings, say, the incentive's not there. In fact, the incentive is all in the other direction. So business models are one of the barriers to better artificial intelligence searching. To some extent, the business models and the way we've organized the scholarly online landscape are as much a barrier as the technological issues that have to be overcome with a computer searching. Available metadata sources are siloed. Obviously, they're in different databases. Some of those restricted or only partially available. They're not really interoperable, and there's no single source out there that's comprehensive. Probably if we took all of the online sources that were available to us and we looked at all of them, we're coming pretty close to having a comprehensive landscape for what's available for scholarly research, but no single search. Even Google Scholar, Semantic Scholar with, as I say, over 200 million articles, they're not yet comprehensive. Now, again, it very much depends on what you need in terms of your research needs. If you are trying to find a few good articles, the current capabilities of AI will probably do the job for you just fine, but it's important for us as practitioners to understand that what the limitations are, and when the tools won't yet do what we hope they would do. So changes, there are changes ongoing all the time. AI is moving so quickly that new approaches are coming up very, very rapidly, and this puts pressure on the metadata providers to think about what do they need to to take the search capabilities to the next level. Of course, I think they're obviously thinking, okay, well, we want to do that because that would be very popular with our users, but they're obviously going to have to think about how to monetize as well. Metadata source interchange and cross comparison is happening. To some extent, things like Crossref and OpenAlex didn't really go down the path of trying to get comprehensive metadata about the scholarly environment because they were thinking about AI. They had other reasons for doing it. But this will be as we get a more comprehensive and a more complete set of metadata available, that will be a major enhancement for AI. Hopefully, it will put pressure on people like Google, who release very little of their metadata and don't work well with anybody else. The big commercial companies like Clarivate, ProQuest, they're gathering huge amounts of metadata and and building commercial products on top of it. And then obviously we have people like Semantic Science and PubMed and ERIC and other open access sources. So this stuff is changing very rapidly. It's important for automated methods to be used for the creation of metadata before searches happen, rather than trying to, say, look at the subject headings that that are used by articles that cite an article that you're interested in on the fly while you're doing searches. So the pre-development of the automated methods for enhancing metadata, adding metadata about what is the subject, what group of articles does a particular article fit into. Doing that pre-search is one way that that the whole environment is getting moved forward quite rapidly. Network mining, what I just talked about, is that there's plenty of information to be derived, and the semantic search people have been talking about this for a long time. That the articles that an article links to, who are the authors, what subjects or the authors searching that may not working on that may not be mentioned in a particular article, but you can go and gather information about the authors, about co-authors. You can gather information about citations and references. Takes a lot of computing horsepower, and there are plenty of other questions to be answered about, the costs and, the pros and cons of doing that. But it needs to be done to enhance metadata, so when it comes to searching, that information is already available. Something that the Allen Foundation is already working on is enhancing metadata with restricted content. So going to major publishers and deriving subject information, and other information that can be put into metadata without actually giving anybody access to their subject headings, or proprietary information that they're still trying to monetize. That has its advantage. Obviously, we would rather that metadata be openly available, but it is a way of improving the quality of AI searching. And finally, I think anybody who's worked with something like ChatGPT, the whole business of prompt construction, that artificial search tools build their understanding of the concepts you're looking for, at least partly based on previous searches. So if you do a group of searches, you ask a question, you don't get quite the answer you want, so you ask another question. The AI can look at your previous question, and it can start to build a better picture of what the concepts are you're really looking for. That's promising. It obviously has a downside, if you change streams and decide to ask a new question, it's one of a number of ways in which we're going to see AI get better in the near future. I figured that people would be skeptical of hearing from me, so I decided to go to authority. So I had a chat with ChatGPT about this whole question. And after talking with it for a bit, I asked it how important the quality of metadata is for the mapping of concepts, correctly mapping concepts to keywords. And ChatGPT was happy to tell me that the quality of available metadata is critical for AI systems to accurately map concepts to keywords. And it went on to talk about why that's the case and the things that AI is doing with the metadata to try and get a better understanding of the concepts you're interested in from the keywords that you're using. From that, I think we've got a few minutes, but I'd love to take questions. Let me just open up the chat here. You see hellos from other Canadian libraries. It's nice to hear. Anybody who has a question, if you would put it in the chat, I'll be happy to take a few minutes. Here we go. Somebody says, forgive my snark. Half the time students don't know what their intent or meaning is. Takes digging to find out what it is they're really asking. And that's absolutely the case, that, people have not thought very deeply about their concept. So yeah, the reference interview is still critical and probably always will be. Other comments? Yeah, the information need versus information want. Absolutely, it's always been the case. Yep. Well, English is a hard language to learn because of homonyms, synonyms. I think any language, this is a problem, and I never set out to be a linguist, but the more I work with online searching, the more I realize that, yeah, that one has to understand the limitations of language. And yes, prompt construction. Yes, so a better prompt makes for better results to some extent. And that's, there are now a number of books being written on prompt construction, more with large language model, where the computer is learning what it is that you want when you're talking to it. But something like ChatGPT doesn't attempt to have a big enough metadata set to be a scholarly article or a scholarly material search tool. I don't I know only a little bit so far about AI methods to automatically generate metadata. But as I said, semantic searching has been going on for a while, where you want to pull together essentially a network of all of the articles that any particular article is related to, and then draw information from those. So even if you don't have metadata about your article, if you've at least got citations or links to authors, you can find out what are the subjects of the things that they're writing about. What are the basic concept areas that are being worked in. It, as I say, it can be a powerful tool, but it does take a lot of processing power. And somebody like the Allen Foundation, another question is, can I comment on the Allen Foundation? Again, I don't know a huge amount about them, but Tim Allen made a great deal of money, and is investing some of it back in, in artificial intelligence research and quite a number of other activities. And the ability to have a foundation with millions and millions of dollars at its disposal has greatly helped. When you ChatGPT is also funded, but ChatGPT is largely funded by venture capital. Quite a bit of it, I understand, coming from Gates. And I don't know what the future of the artificial, and there are some good papers on on what the Allen Foundation folks are doing and the problems that they've run into. A lot of the ones I've talked about. But again, I'm not sure their interest is in advancing the cause of artificial intelligence searching, not necessarily in building the best scholarly research metadata repository. So, the two interests come together at a certain point. But there's certainly opportunities, I would hope, to talk to the Allen Foundation about really helping out people like OpenAlex. Somebody commenting that generative AI has not yet been taught the humility of saying, I don't know. I have to say that I don't necessarily agree with that. I'm quite pleased with ChatGPT's ability to say, well, sometimes I don't know, or I am not the right person to ask. ChatGPT is surprisingly good at saying, you ought to go and search Scopus for that because I don't have the information. And my data set was last updated at the end of 2002 or whatever it is at the moment. Okay, we've got about 30 seconds. I'm sorry if I didn't get to everybody's questions. I have put my email there. Certainly, if people want to carry on the conversation or you've got something that you want to exchange, feel free to send me an email. But I think I ought to give you guys a couple minutes to get to the next session. So with that, I will say thank you very much, and hope you enjoy the rest of the mini conference.
Peter, are you done?
Yes, I am. Thank you very much.
Thank you. We're going to stop the
Did you need
stop the
something?
recording
Sorry,
and we'll close the room.
Doing the previous sessions.